Okay, folks, looks like it's time to get started. We're live. We're going to be talking about ParallelFox 2.0. Before we get started, just a little bit about me. I'll click in. I've spoken a few times at Virtual FoxFest. This is the first time I'm doing a full session in person. So mark that off the bucket list. And so hopefully it goes well. I'm also the project manager for several VFPX projects, including ParallelFox. You can find my blog at joelleach.net. You can also find me on GitHub, Twitter, and YouTube. And like most of you, I've been doing development for a very long time. FoxPro is my true love. But these days, I spend at least much time with these other technologies like .NET and SQL Server. So before we get into the agenda, I thought I would just say a few words about ParallelFox 1.0. This was brought to life back in 2010, and version 1.0 was released in 2011. And this was kind of an exciting time for parallel processing because do it closer. Oh, turn it on.
Bingo.
When all else fails, turn the power on. Okay. Yeah, so this was an exciting time for parallel processing because you were seeing these libraries pop up for .NET, for Java, really the wider development community. And so I was happy we could include VFP in that movement. But of course, I've always wanted to add more features to it. And so we're finally getting some of these features out in version 2.0. In fact, some of the features you're going to see today were conceived, prototyped at this very conference. I can remember, it must have been 2012, 2013. I was up in my hotel room, just fueled by inspiration from everything I had seen at the conference. Ideas were flowing from my head to my fingers into code. I was in the zone. And so I was able to get a lot done in just a few hours at the conference. Over the years, I worked on some things here and there. And then finally, while working on this session, I finished up some other features that I've always wanted to add. It's one of the reasons why I picked this session in the first place, so I could get that done. So you could say ParallelFox 2.0 is over a decade in the making. Or you could say my procrastination knows no bounds. Either way, I'm happy to finally be getting these features done and showing them to you today. Now, when I released ParallelFox 1.0, I included some training videos, lots of examples. There's a help file. That's all still relevant. So we're not replacing any of that today. I'm taking a little bit simpler, different approach. So definitely continue to use that as a resource. And if you're an existing user, developer with using ParallelFox, 2.0 is backwards compatible. Now, I will say that in a previous release, I did update ParallelFox EXE. So if you just happen to be using a very old version of that, then you might have to update that. But as far as code changes, none of that is required. So for our agenda, even though I'm highlighting ParallelFox 2.0, you don't need to know anything about ParallelFox already. We're going to answer the question, what is ParallelFox? We're going to get into the basics of how to use ParallelFox. Then I'll share some tips, tricks, and traps that I've discovered over the past decade or so. And along the way, I'll point out any features that are new to ParallelFox 2.0. Those of you in the room, feel free to interrupt with questions, and I'll just stop occasionally for the online folks. Okay, so what is ParallelFox? Well, it's a parallel processing library, and I should probably say what that means. Basically, it means running multiple bits of code simultaneously in parallel. It can also mean running code in the background while you have something else going on in the foreground. If that sounds a lot like multi-threading, it's actually more than just multi-threading. So consider .NET version 1.0 was released in 2002. That version had multi-threading support right from the start. But it wasn't until .NET 4 in 2010 that they released the Parallel extensions library. So ParallelFox fits in that same space, right? And Microsoft must have seen that multi-core PCBUs had become mainstream and realized they had to just make it easier for developers to tap into that power. So yeah, there's other ways to do multi-threading, multiple processes in FoxPro, but ParallelFox is really an entire library that is focused on running in code in parallel, and helping you do that with your code, and significantly reducing how long it takes to run that code. So here's a diagram that shows the basics of how ParallelFox works. We'll start with the main process, and that's where your typical VFP application has always run, including the user interface. Now, what ParallelFox provides is a pool of worker processes, and this is where code can run in parallel or in the background. And the number of workers is configurable, and I just have 4 here on this diagram. So you write code that runs in the main process that uses ParallelFox to send commands to the workers. And what ParallelFox does is packages up each of those commands and puts them in a queue. And each command is then sent to an available worker to be executed within that worker. And the communication between the two, the main process and the worker process, is done via COM. Now, each command is executed asynchronously in the worker. So that means as soon as that command is passed off, then control returns back to the main process and it can keep running. And since we have multiple workers, we can run multiple commands at a time in parallel. Now, when a command completes in one of these workers, it grabs the next command off the queue and sends that to the next available worker to run. And that process just continues until everything in the queue is complete. So that's the basics of how it works. How about a peek at our first new feature? New in version 2.0 is the ability to do this all in one process. So this is the same diagram. The only thing that I've changed is that these workers, instead of being processes, they are now threads, and all of this lives within one process. So let me show you a little code or an example for that. I don't worry about too much about the code here. What I really just want to show you is that I'm going to first run using the default out of process workers from that first diagram. Then we're going to take a look at the task manager. And then I'm going to run it a second time using the in process workers, and we'll see how that looks in the task manager. So let me start this.
I'll be back.
And if we look over here in the details, I can see, now I'm going to try to do the magnifier. It's Command Shift plus, is that right? Oh, there we go. Let's try that again. Okay, so you can see I have 4 instances of ParallelFox exe running here. Those are my 4 workers that are running out of process, which again is the default. Okay, and so I'm going to go back here and press OK. And then if I go this time I'm going to look at my VFP process. And if you look over here, you can see that VFP9 currently has 6 threads running. Now I have not started the workers yet. So I'm going to go over here and press OK again. And now you can see I've got 10 threads. So 4 of those threads are now my worker threads. Okay, and I don't need to use the magnifier anymore. Okay, so let's talk next about the basics of using ParallelFox. And what I want to show you is just how a basic program that you would write to use, the basic flow of a program you would write to use ParallelFox. So I'm going to look at some code again for that. And to start, we first need to create this parallel object that is included with ParallelFox, and that's how we do most of our interaction with it. Then the first step after that is to make whatever configuration settings we need to make. One of those is setting the number of workers. Now the default is 1 worker per logical CPU. So if you have an 8-core machine and that CPU has hyperthreading and that gives you 16 logical cores, by default, ParallelFox is going to create 16 workers. And that's a pretty good place to start. Then you can do some testing and see if you need to raise or lower that. And here I'm just setting it to 8. I've got 4 cores on this machine right now. The next step is to start up those workers. And this start workers command accepts a first parameter is a procedure file. So what's going to happen is it's going to perform a set procedure to command within each worker for the file that you give it here. And that's typically an app or an exe. I usually use the same app or exe that I've got running in the main process. But if you wanted to segregate your worker code into a separate app, that's certainly okay. And just like standard FoxPro, you could set it to a PRG. So that might be good for debugging or for examples like I'm doing here. So I'm just setting the procedure to basic flow PRG, which is the same program I have open because the code I want to run in the workers is housed inside this PRG. And the next step is to run your code in parallel. So again, each command we send is going to be added to a queue, and then from the queue they'll be sent to the workers to run in parallel. I'm using parallel do to execute that. There are other ways that we're going to talk about to run code, and I'm calling this procedure named simulate work. So if I scroll down, there's my procedure, and all it does is count to a high number. It turns out that's an easy way to peg a single CPU, single core to 100%. And so if I go back up, I'm running this command 80 times. So that's going to add up to 80 items to the queue. And since I have 8 workers, 8 of those will run at a time simultaneously. Now my next command is to run ParallelWeight. That's going to pause the code here in basic flow PRG and until all 80 of those commands in the queue are complete. And that step is actually optional, and we'll talk more about that later. Last step is to stop the workers. And so by calling this, it's actually going to shut down those worker processes or threads so that they're no longer in memory. And just so I don't mess up the rest of my demos, I'm setting the worker count back to the default 4, which is 4 on my machine, and ParallelFox gives you an easy way to get to that number. Okay, so that's the basic flow. Let's look at the various ways to run code in parallel. And they mirror basically all the ways you already know of how to run code in VFP. And they're listed here, but again, let's look at, it's easier to see in code. So I've got my worker started up, and the first way that I can run code is by calling parallel do command, and that's going to execute a single command within a worker. And that might be good for things like environmental settings. And all of these ways I'm going to show you to run code, they all include this parameter that gives you the option. No, no, you can't see that, but gives you the option to run it on all the workers. So that means I'm going to run set exclusive off on all 4 of my workers before those workers do anything else that's queued up below it. Then the next way to run code is parallel do, and as the name implies, that's going to execute a program or procedure within a worker using the do command. So in this case, I am calling run units, and I'm passing it a parameter of 10. So if I scroll down, you can see here's my run units procedure. It accepts a parameter, the number of units, and it just calls simulate work that many times. Very simple. The next way is parallel call. This is for calling a function. So that could either be an internal VFP function. So in this case, I am calling the version function with a parameter of 1, or it can be your own code, a user-defined function. So very similar to do, but like standard FoxPro, whenever you call a program as a function, it'll give you a return value. If you call it using do, it does not. So if you want a return value, then you need to use call. This is the same code that we ran before with the do, and I'll show you later how we get to that return value. Now, some of us like to use this thing called object-oriented programming. So the code or function you might need to call is actually method in a class. And so ParallelFox gives you an easy way to call that using call method. And so what it's going to do is instantiate that class, call the method, release that object. Okay. So you give it the name of the method you want to call, then the name of the class, and then the class library where that class is contained, and again, any parameters. Lastly, you can execute a script on a worker. So here I'm building up a script as a string, and scripts can accept parameters. So I'm just taking that parameter. In this case, I'm just going to multiply it by 2 and then call the same run units I've been calling before. Then I use parallel exec script to execute that script and pass it a parameter of 10. So that will end up calling run units, sending 20 to run units. Okay, so those are the basics of running code. Before we move on, are there any questions?
Yeah, we have one from the virtual audience. I was not clear on how ParallelFox is different from multi-threaded apps. Repeat it first.
I believe it just has more features. It uses multi-threading.
No, you need to
Oh, okay, sorry. The question was, how is ParallelFox different than multi-threading? Just think of it as a higher layer, a higher level application, right? Multi-threading is a lower level. It uses multi-threaded or multiple processes, but it gives you an easier way method of running your code in parallel, just like libraries on .NET, Java, these other places. Yes?
What are the limitations of a worker? I mean, are there some commands you can't do?
We're going to talk about that. The question was, what are the limitations of a worker? For the in process, there definitely are some. We're going to talk about that later. For out of process, it's not as much as you would think. I mean, typically you don't want user interface in there, but if you really wanted some user interface running those workers, you could do it. So yeah, yes.
Are these examples now using 1 or 2, version 1 or 2 of ParallelFox? I mean, are we looking at threads or processes?
I've been using, except for that first example I showed you, I'm using out of process for all of these, but any of them would work that I'm showing you would work with in process. Yes.
Each worker has a private data session, or
The question is, does each worker have a private data session? Each worker is actually a separate process. And so like a separate instantiation of your application. So running multiple, and with the in process, instead of separate processes, it's separate threads. But think of each one having its own Visual FoxPro environment. Yes, in the back.
Are you going to touch on the benefits in process versus out process?
Yes, I'm going to talk later about in process versus out of process. And
so you can actually expand
I don't think about it that way. I suppose that is true. The question was, can you expand? You can actually expand the amount of memory you use with ParallelFox. In the sense that there are multiple workers and each of those has what, a 2 gigabyte limit. Yes, but really what you're doing is tapping into all of the cores of your CPU rather than the default, which can only use one core or one thread to run your code. Yes.
If one of the parallel processes fails as an exception, how will that be reported back to the main program?
The question is, if one of the processes fails, how do you report that back to the main program? I'm not sure it's good. You're going to answer that directly, but we are going to talk about error handling later. Okay, I'm probably better move on. So while you can fire a command and forget about it, right? Just let it run. It's probably a lot more useful if the workers can communicate with your main process. For example, you might actually want to know the result of the code that you run in a workers. Or maybe you've got a long process running and you would like it to report progress of how long, the progress of that task. And in ParallelFox, this is done by means of worker events. And the syntax is very similar to VFP's bind event. So it should be familiar to those that have used that. And ParallelFox includes several predefined events that you can bind to. We're going to discuss each one of these. The first is the complete event, and that fires when a command is finished running on a worker, as the name implies, and that event includes the return value of the command that you ran. So let's look at some code for that. So the objective of this code is very simple. I just want to get the thread ID from each of my workers. So I'm going to run parallel call, and I'm going to call the get thread ID function, and I'm specifying here that I want to run it on all 4 of my workers. So if I look at that code, it calls get thread ID, and that just returns the thread ID. Very simple. Now, in order to do bind event, I need an event handler, right? So I've defined a class here called myHandler with the method print thread ID. Now I told you that the complete event includes the return value of the command that you ran in the worker. So this function must accept one parameter or there's going to be an error. And then I'm just printing this out, the thread ID within the main process. Now to actually hook that up, I need to first of all instantiate my event handler, call parallel bind event, indicate I want to bind to the complete event. Then I pass in the object and the method name just like you would with standard bind event. Now you need to do this before you send any commands to the workers that you want to respond to, just like standard VFP, right? If you want to bind to event, you better set up that bind event before that event fires, right? So same idea here. And so I can run this code now. And you can see here I've run that in parallel on all 4 workers, and they all returned the thread ID, and that's displayed here in the main process. Now, typically, your event handler is probably going to be more complicated than this. Maybe there'll be multiple lines of code. And so you would typically do it this way that I've shown you here. But sometimes you can get by with a single command. And this is one of those cases. So it's a little bit of a hassle that I need to set up a separate method just to handle that event. So new in version 2.0 is the ability to send a string as a 1-line command that can run in response to that event. So you can see here in the second parameter here, instead of sending an object, I'm just sending a string in to print out that command, to print out that thread ID. Now, when you do this, you need to know the internal names of the parameters that ParallelFox uses. So I have to use the T parameter 1, T parameter 2, etc. to get to those. Another important point to make is that this command is not going to run in the scope of this PRG that we're looking at right now. It's going to run later. So it's not going to have access to any local variables you would define within this program. But you do get access to the parameters passed back by the events. So now if I run this, it's the same type of result, but I did it with less code. Now this complete event, it works great whenever you need to get a single value back from a worker, but sometimes you might want to get multiple values back. And so the return data event is useful for that. Now I say return data, but what I'm really talking about is multiple variables or multiple parameters coming back from the workers. So let's look at some code for that. And this is a very similar example. This time I'm calling get worker info. And again, I'm doing it on all of the workers. And the complete event, ParallelFox can fire it automatically whenever that command has completed. With the return data, you need to explicitly fire it. So to do that, we provide, ParallelFox provides this worker object that's designed for to run inside your workers. And then within the worker, you call worker return data, and then pass back whatever variables you want to get back to the main process. So this time I'm doing the process ID, the thread ID, and sys 2015 for a unique value. And then my bind event works very much the same way. Let's see. And this time I'm binding to the return data event instead of the complete event. And I'm just saying here that I want to print out first parameter, which is the process ID, second parameter, which is the thread ID, and then my unique value. So let's run that. And there's the result there. I will point out, it didn't show up this time. Sometimes you're going to see this unique value is not so unique whenever you're running it at the same time in parallel. So check out the white paper for a solution to that problem. Okay. What's next? Go ahead.
So if we're trying to do something parallel to, say, get UC build for back or something, I would guess in the back of the variable, that's going to have some string type of string type thing.
The question is, how do I get data back, like in the form of a cursor, to the main process? And that's coming up soon. But as far as return data, you're calling it explicitly, right? Each time you want to return data, there's nothing stopping you from calling that in a loop. So you could actually use that if you've got a long process running, you could use that to stream data from the worker back to the main process and display it in some way while that long process is running in the worker. And there's a demo of that in the downloads. And that might make you think return data would be a good way to report the progress, right? How much, what percentage of the process is done. But actually, ParallelFox includes an event expressly for that purpose called the update progress event. And it's a little bit different than return data because the problem with progress updates is that the overhead of reporting the progress can be disproportionate, right? So you might have your process might take a certain amount of time. You add progress reporting to it. Now it takes 2 or 3 times longer. No thanks. So the solution to that is just to limit how often that progress update fires and how often it's sent back to the main process. And that's exactly what the update progress event does. So let's look at an example of that. This time I'm calling run units with 50 units. And if you look in here, I have added the ability within the run units to send progress updates back to the main process. And you can see it's going to run for every unit of work that runs here. But by default, ParallelFox is not going to send an update any more than once per second. But you have control over that. So in this case, I've set the progress interval to 0.5 seconds. And the update progress has 2 parameters. The first is a number indicating the percentage complete and a message to go along with that. So how do we then view that progress in the main process while that's running? I'm using a thermometer here that ships with FoxPro and the FFC. And so it just so happens that the thermometer update method has the same interface as our update progress event. So in other words, the first parameter for update is that number indicating the progress, and the second parameter is a message to go along with it. So since it has the same interface, I can just bind directly from update progress to my thermometer update. If I had a progress bar with a different interface, then I would need some kind of wrapper to handle that transformation. And let's see. So let me run that for you. And you can see it's not firing, it's updating, but not for every unit that is being executed. And I could change this to 0 and may force it to fire for every unit, but then it would take a little bit longer to finish running. Okay, cursors. And I don't have to explain to anybody how useful that would be, right? Compile a cursor in your worker and then return that back to the main process. And so the return cursor event is useful for that. So let's look at that code. This is just a very simple example. So I'm running get USA customers. First of all, I set my worker count to just 1 for this example. I'm calling get USA customers, and that's going to run this query, which just pulls some data from my sample Northwind database. And then I call worker return cursor to return that back to the main process. Whenever that fires, that's actually going to automatically open that. It's going to return that cursor back to the main process and actually open it for you. So whenever you get to this point, I can just select that cursor and browse it. So let's run that. So there it is. The query has run in the cursor, and it has opened up in the main process. Now, that's not very useful. It's just one query, but you can imagine a scenario. Has anybody ever had to run multiple queries and then consolidate them because you couldn't do everything in one SQL statement? you can imagine a scenario where maybe you've got 2 or 3 queries you could run in parallel, return all 3 of those back to the main process, and then consolidate them in a final query there. And there's an example of that in the downloads. Okay.
If you were going to do that, you need to be careful about naming, because if you return 2 cursors with the same name, I assume there would be problems.
The question is, you would have to be careful about the naming of the cursors so that when you return them, you don't have multiple cursors with the same name. I think you're correct. I'm trying to think if 10 years ago, did I do anything to prevent that from happening? But I think you're correct. You would want to have different names for each cursor in the worker, because I'm going to use the same name when it returns it.
Just on that, you said each worker runs in its own thread, right? So it's not until the return value that you've got to care about the names being different. Is that correct?
Correct. Right. Yeah. So each one runs in its own process. It's not until you return it that you have to worry about the alias name. Correct. Yes.
Yeah, I had a very similar situation, and I found that creating a parent cursor in the calling program and updating that creating a parent table in the calling program and allowing each of the worker processes to update that cursor kept the parent program informed of the progress on each of the threads.
Right.
And that was very helpful.
Right. That's another way you could handle the progress by using
The idea.
the idea was opening a parent table in the main process and then basically reporting the progress through it. Right. So that's another way you could handle that. Okay. So here's my diagram again, and I've just added the events returning from the workers back to the main process. Did we have any online questions? Okay. Error handling. This gets a little bit interesting. Things can get a little bit tricky because you actually have 2 error handlers in play. You've got one in the main process. That's the one you all know very well. And then there's another error handler that's going to be used inside the workers. So everyone's error handler is a little bit different, right? So ParallelFox doesn't try to steer you in a specific direction. It just tries to emulate the ways of error handling you probably already know. And first of all, when an error occurs within a worker, then worker return error is the way that we notify the main process that an error has occurred. And then we can, to set up a global error handler, we can use parallel on handler. So what that means is whenever an error occurs in the worker, how is my main process going to react to that error? So you can do that in a global fashion using parallel on error, very similar to the standard on error. Another way we can handle errors in standard FoxPro is the error method. And so to emulate that, you can use parallel bind event, but you bind to the return error event, which I didn't bring up before. But that is also another event you can bind to. And that ends up being very similar to the error method way of doing error handling. And like standard FoxPro, this will override the global error handler if you put it in place. Now, what about try-catch, structured exception handling? Yes and no. You can use it in a worker to catch an error, right? And then in the catch of that structure, you can call worker return error to notify the main process. You can't have a try catch within the main process that's going to catch an error that occurs in the worker. And when you think about it, that's a very synchronous way of thinking, right? Because that relies on the call stack. So ParallelFox commands run asynchronously. So probably by the time an error fires, you would also already be out of that try-catch structure. So you can't do it that way, but there are ways to get it working. So if you don't do anything, ParallelFox includes a default error handler. In fact, let me show you that. Okay, so in this case, I've set the worker count to 2, and I'm just calling this cause error procedure on both workers. And you can see here, I've just got it firing, causing an error. So if I run that, then ParallelFox includes this very simple screen. And sorry, I didn't make the font bigger on this, but it actually reports the error twice. Why is that? Because the same error occurred in 2 workers. And so this simple screen will just display both of them for you. If you wanted to set up a global error handler, and again, that's if you do nothing, then you would use the parallel on error. And again, this says whenever an error occurs on the worker, run this command within the main process. So if I look at that code, in this case, I'm just accepting those parameters. These are the parameters that are returned from that worker return error. And I'm just building up a string and displaying that in a message box. And in this case, I'm doing it just one time. So now I've got my error displayed just in a message box. And there's a very similar example of this using the error method and the bind event in the downloads in the white paper. Now for these examples, I changed the error handler in the main process, but I left the default error handler in place for the workers. But you could change that as well. So you might want to think about, when do I want to do my error logging? Should I do that in the worker, or should I just pass it back and let the main process do that? However you want to handle it, you have control of that. There's more information on that in the white paper. Now, if you have errors, you're probably going to need to do some debugging. And normally this is an issue when you're dealing with COM. There's not an easy way to debug, but ParallelFox makes it easy by providing a debug mode. You simply start your workers using that debug mode, and you can insert set step on statements in the code that's going to run on the workers. And so let's look at an example of that. So again, this is basically the same example we saw before, except I'm passing true as this parameter, which indicates I want to start my workers in debug mode. And I don't want to do the set step on yet. So I'm going to run this. And again, I've got 2 workers. So what happens when you run in debug mode is, instead of starting up that ParallelFox exe or a thread, it runs a full instance of VFP and runs your code within that instance. It also makes that visible, and it also turns off that default error handler. So any errors that occur will actually pop up on the screen, and you can respond to them. I can suspend here. I can open the debugger, and you can see there's where my error has occurred. And I'm just going to ignore this so it closes cleanly. And again, I had 2 workers, so I have 2 errors. I'm going to ignore this one as well. And I want to run it again. This time I'm going to put set step on in my code. And again, anywhere you can put that anywhere you want to within your worker code. I run it this time. Okay. Okay, yeah. So you see, I get 2 debuggers. So that might be a little weird, especially if you're running 16 workers. You might get a lot of debuggers there. But you might want to just reduce it to 1 while you're debugging, right? But yeah, there's the setup on, and you can continue to debug from there. And again, I'm going to ignore each of these so they don't mess up the rest of my session. Just a quick word about deployment. It's pretty simple. Include ParallelFox VCX in your projects that are going to use ParallelFox. If you're going to use the out-of-process workers, the default, you need to deploy and register ParallelFox EXE. If you're going to use the in-process workers, you need to deploy and register ParallelFox MT DLL and accompany that with Christoph's demult DLL. Now, this ParallelFox EXE has very little code. It's designed to change very rarely, if ever. But it can still be a hassle to have to register it, depending on how you're deploying things. So new in ParallelFox 2.0, it's a cool new feature that allows you to do reg-free COM for these out-of-process workers. I don't have time to demo this, so check the white paper out for it. And this idea, anybody in here that's familiar with COM, the idea of reg-free for out-of-process workers might be a little bit foreign. So if you want to find out how I pulled that off, then take a look at my blog. For in-process workers, we've been able to do reg-free COM for that for a long time using a manifest. So that's possible as well. Do we have any questions? Yes.
Yeah, where you've got multiple workers and they're all running in parallel, and you've got a body of events that's going to call some method back into the main program when those workers are done doing their job. Do you have any recursion issues to deal with in the main program?
So the question was, whenever you, I'll try to summarize it. Whenever you fire a worker event and that calls some code in the main process, is that going to cause any recursion problems in the main process? Well, I'm not sure if this is the exact answer, but I will tell you that FoxPro has a unique ability to, I think it's unique, to whenever those events fire, to interrupt any code that is already running in the main process. Fire your code that's binding to that event, and then return back to the code where it had before. And there's a setting for that called auto yield. So you need to make sure you have that turned on. But in terms of recursion, I have not run into any problems with that. Any other questions? Okay. Okay, let's go over some tips and tricks as well as some gotchas for parallel processing. Now that we've got these in-process workers in ParallelFox 2.0, is that the new recommendation or is that the new default? No, the default is still going to be these out-of-process COM EXEs, but there are pros and cons to using the in-process. So the main pros are lower resource, lower memory usage for the in-process. It also has less overhead and faster throughput. So I've got in one of my automated tests, I have a stress test that puts a heavy load on the ParallelFox infrastructure. So just think a whole bunch of hello worlds running on a whole bunch of workers, make sure it can handle that. And this test takes about 25 to 30 seconds whenever you're running with out-of-process workers. Run that same test on in-process, and that brings it down to about 2 to 3 seconds. So it can be quite a bit faster. That said, in real world scenarios, that even that out-of-process overhead is probably going to be negligible compared to the code that you're running within the worker. So we'll talk more about that in a little bit. The cons is that it uses the multi-threaded runtime for VFP, which has some limitations. For example, there's no report engine there. There are some other things that are missing. Some of the things that are there might work a little bit different than you expect. And so when someone is adopting ParallelFox, they're typically taking some existing code that they have and adapting that to run in parallel, right? And so if you have to, on top of that, deal with these limitations of the multi-threaded runtime, then that whole process could take longer. And so I like to think about it, if I have a small piece of code with just few dependencies, and I don't think I'm going to run into these MTDLL limitations, then yeah, I might opt for the in-process workers. If I've got code that relies on my entire framework, that framework has not been vetted to run in an MTDLL, I'm not about to try to fit my whole framework or adapt it to that. So in that case, I would just go with the out-of-process workers. Now, suppose you have some code that can run in parallel that you could use in the end process workers, and you've got some other code that can only run out of process. Maybe it's a report. And suppose you take it a step further and you want to run those two things at the same time. Well, that would cause you a problem, but in ParallelFox 2.0, we now have the ability to have separate named instances of ParallelFox. So each instance is completely independent. Each one has its own queue, its own set of workers, its own events. And check the white paper for example of that. Now, most of our examples have included the ParallelWeight. And again, that pauses the code that's running the main process, finishes everything in the queue, then allows that code to continue. That's not necessarily a requirement. So if you wanted to run a background task, then you could exclude the wait, right? So your goal in that case is while that background task is running, you want to return control, keep running code in the main process, or just give control back to the user, right? So no wait in that case. In other scenarios, you really don't want the user doing anything while this process runs, but you would like to reduce the amount of time that it takes. So in that case, you would want to keep doing a ParallelWeight, but obviously you're writing your code in the parallel to bring that whole time down. So I do want to show you one thing.
Quick question.
Yes.
What happens if we don't want to wait up and do actually your mini program? What will still run it? Does it matter?
Could you repeat that?
If your main program ends, you quit, and the parallel process is still running.
First of all, you would want to call parallel stop workers whenever you're on shutdown. But ParallelFox also has it checks to see if the main process is still alive, I think once per minute. And those workers will shut down automatically if it's not there. Does that answer the question?
So you still need, the main program still needs to be there, basically.
Yes, yes.
Okay.
Right. Yeah, so ParallelFox requires both the main process and the worker processes to be active to run. You wouldn't just start something in a worker and then close your main process. And it would not. I mean, it might keep running for a minute and then it would detect that the main process is gone and then close. So I want to take another look at the progress update here. And what I'm going to do is comment out the ParallelWeight here. Now, I'm going to tell you up front, there's a problem with this program now. I'm not sure if any of you see it yet, but let me just run it for you. And you might have seen that, but you might think nothing happened. right? Let's run through the code. We actually started our run units, and then we don't have a parallel wait, so our code's going to continue while that run units is running. Aha, stop workers. Nope, that's not it either, because stop workers is a queued command. So it's going to be put in the queue after run units is complete. Then it's going to shut down your workers. So if I keep going, this code runs as well, and then I get to the end of my code and it finishes. So the problem here is that the code actually did run, but we didn't see my thermometer. The reason for that is that this thermometer is local. And when my program ended, that variable went out of scope like it normally does. Right? So that's something you need to keep in mind when you're using a bind event and you don't have a parallel wait. So I need to somehow keep this in scope. I could make it a public variable. I could make it a property on object that is remaining in scope. I'm just going to do the quick and ugly thing, since Tamar said it's okay. And now I am going to clean up after myself. So I've got this handy piece of code here that says, okay, now release that variable when the complete event fires, which is going to fire after this run of units is complete. So I'm going to save that. Now remember, the reason I've removed the parallel wait is I want to have control in the main process again. So while I run that, you can see the thermometer, but I still have control in the main process. So I could continue running code or give the control back to the user. Now, obviously, in this type of scenario, I don't want my thermometer front and center, right? So you would probably want to move the progress reporting either into the VFP status bar, or you could create a small progress bar that runs on a toolbar, something less intrusive. Okay. So let's talk about a scenario where maybe you want to import some data and into your system and then process it. Now, importing the file from CSV or Excel or whatever, that's already pretty fast, right? So your parallel processing is not going to help you out much when it comes to that. It's what you do next with the data. Okay, so maybe you need to validate every field and every record, and there are thousands of records. Or maybe you need to process every record through your system, and it takes a couple seconds for each one. This is where parallel processing can come in and help you. That's the time-consuming bit, right? So we're going to use this scenario just for the next few examples. And I just want to show you like the basic of doing that first. So instead of actually importing data, I'm just running a query to create a cursor. So you can say this is a substitute for the import, or maybe I'm validating data that's already exists, whatever. So now I'm going to scan through that cursor, and I'm going to call scatter with the to an object. Then I'm going to call validate order with that object. So with this technique, I am making a separate call to validate the order for each record in the cursor. So if I'd done this in the main process, I can only validate them one at a time. If I've got 4 workers, I can validate them 4 at a time, right? So let's look at that validate order. And that just accepts that order as a parameter. And instead of actually doing any validation, I'm just calling simulate work. But this is where your actual validation code would go. Okay, so that's a basic of how you can do process data. So let's say that each of these validation calls takes a few seconds or maybe longer to validate each record. In that case, we're good. This process works great. But what if it takes significantly less time than 1 second? Let's say it's 100 milliseconds or less. At that point, you're going to start seeing diminished returns because of the overhead that ParallelFox and COM add to the process. That might be a good time to consider those in-process workers to bring that overhead down. But another good strategy is to validate a batch of records with each call to a worker. So let's look at a way you could handle that. So again, I've got my cursor here. Now we looked at return cursor earlier as a way we can return a cursor from a worker back to a main process. In order to do this batch validation, what I want to do this time is go the other direction. I have this cursor in the main process. I want to share that with my workers. So new in ParallelFox 2.0 is the ability to work with temporary tables. It will create a temporary table from the cursor that you specify. And that temporary table will be given a unique name. And then what I want to do next is open that temporary table on all of my workers. So that's all the workers, and I'm going to pass in the name of that temporary table. So if I scroll down, that's just causing this new open temp table. And then within the worker, I've given it the alias name USA workers. Next is to validate the batches, and I'm setting my batch size to 10 for this example. It could definitely be higher. And instead of a scan, I'm using a 4 to count through all the records, and I'm using the batch size as the step. So what's going to happen is each time when I call validate batch the first time, it's going to send the starting and the ending record of the batch. So the first batch is going to be records 1 through 10, and that'll execute on the first worker. The next call will be records 11 through 20. That'll be on the second worker. 21 to 30 will be on the third worker. I'm getting a lot more records in the validation with each call and reducing my overhead. Then whenever I get done, I want to close that temp table and then finally delete it to clean up. So that's batch processing and the new temporary table features. Now, if I'm validating a large number of records, it would be nice if I could cancel the process in a graceful manner. And ParallelFox 2.0 has a new cancellation feature to facilitate that. So let's take a look at it. And this is the same code I just showed you, except I've added a bind event here to display each order as it's validated, just so you can see something on screen that's happening while the validation occurs. And if I go down to my validate batch, I forgot to show you this before in the other program, but I'm sending in the start and end record, and then I'm just scanning through those records and calling validate order for each of those records. What I've added here in this program is, sorry, I got ahead of myself. This is the next new piece. I'm just going to pop up a message box in the main process here. It says press OK to cancel. That's not confusing at all. You really want to confuse the user, add a cancel button to that message box. Now in a real application, you'd have a progress bar, maybe with a cancel button on it, or a message that says press escape, but we're living on the cheap here in demo land. So all it's going to do is pause this code, and then whenever I press OK, it's actually going to call parallel cancel. And what that's going to do is immediately delete anything that's remaining in the queue. And that may be good enough. And that's all you do. Any batches that we're currently running in the workers, they'll finish running their batches, and then they'll see that there's nothing left in the queue, and the rest of the code will complete. But you can take it a step further, and within the worker, you can call check to see, call worker is canceled to check and see if that parallel cancel was called. Okay, and if it is, then I'm just going to return a message back and then exit that loop. I don't want to finish the batch. Okay, so if I run that, oops, I don't close it before I run it. I'm going to put it to the side so you can see. It's a little bit slow to run the cancellation, and that process has been canceled successfully. Yes, question.
When you hit the cancel method, that sets the is canceled for all of the current workers?
Yes, yeah. The when you call parallel cancel, it actually sets the actually when you call worker is canceled, it actually calls back into the main process to check if the cancellation has occurred. So there is a little bit of a performance hit with that. Okay, we're a little bit behind, so let me keep going. And talk a little bit about concurrency. Parallel processing brings concurrency issues with it, especially when you have multiple workers competing for a shared resource. Might sound a little bit familiar. A lot of us have become experts when it comes to data concurrency, right? Whether you're talking about locks and records and tables or transactions. But it's not just data concurrency you have to worry about. The shared resource could be anything, even a piece of code. So take this example where I am creating a table on a network drive, and imagine you have, this is a multi-user situation. What are the chances that you have two workers, or two users rather, that run this line of code exactly at the same time on two different machines? They both enter the if condition, and then they both try to create this table, right? Near zero, right, to quote Oppenheimer. Now, what if you run the same code in multiple workers? Your chances go way up, right? Because by definition, you're running them in parallel almost simultaneously. So the creation of the table here then becomes your concurrency issue. You really only want one worker to create that table and the others to move on, right? And so we address this by designating this code as a critical section. And so what that does is within your worker code, you can call worker start critical section. That places a lock on this section of code. It's similar to a database lock, except it's done in memory. And I've given this critical section a name called create my table. Now, if you have multiple critical sections throughout your code, you want each one to have a unique name, not random, but unique so that they don't interfere with each other. And so what's going to happen is the first worker to encounter this code is going to start the critical section and place a lock on it and enter the critical section. Any remaining workers will just wait for that lock to be released. So that first worker will check that the table does not exist. It will see that it does not exist. It will create the table. Then it will end the critical section, release that lock, and that first worker will move on with any code below that. Now that that lock has been released, the second worker can enter that critical section. The remaining workers continue to be paused and wait. The second worker will enter that and see that the table is already created. Then it will release the lock. The third worker will do the same thing. The fourth worker until you get through all your workers. Problem averted, right? Yes.
You could probably speed this up if you flip the if test and put the start critical section just around the create table. Because then once you've done it, nobody's going to have to wait. It'll be there.
The table is still there.
Right, the table will be there, so nobody else will hit.
Yeah, but you could be there from outside. The table must not be created in that process. It exists all the time. So that's what we asked for.
Oh, I see what you're saying.
Yeah.
Well, now, if the table already existed, then you'll never, you won't start the critical section. You'll just skip over the whole block.
getting hit.
You're going to see that in 1 second.
I'm sorry. Steal your thunder.
Yeah, so like a database transaction, you want to keep this code as short and sweet as possible, right? Because you want to limit how long those locks occur. Those locks are relatively slow, so you could do, to reduce the usage of the critical section, you could do basically what Tamar just said and wrap it with an if, okay? So I'm first going to see, is my critical section even necessary? Okay, if it is, then I need to start that critical section. But if you use this technique, you got to check again inside the critical section, okay? So the thinking is maybe the first 1 or 2 workers get into this if, right, this first if, and they need to start the critical section. Maybe by the time you get to the 3rd or 4th worker, that table's already created, no critical section or delay needed for those workers. Okay, I have to go a little bit quickly through this. You can also use critical sections in a kind of creative way. Like one way to avoid concurrency issues is to make sure your code does not run simultaneously, right? So using code like this, I can add a 100 millisecond gap between each of my workers, and usually that might be enough to avoid a lot of these concurrency issues. Now, while the critical section might be kind of a new concept, you still need to be thinking about data concurrency. Make sure you check your set reprocess setting within your workers. You're going to be hitting that VFP's data concurrency probably harder than normal. So you might end up making adjustments to this. Anybody in here use local or remote views? Yes. Then you've probably encountered the problem where VFP locks records in a DBC whenever you're opening a view. And the solution to that 20 years ago was put all those views in a separate DBC, copy that up to the workstation so that DBC is no longer shared. Problem solved. With ParallelFox, guess what? It's back, because now you have multiple workers on that same machine trying to open those views at the same time. Yeah, Bill?
From the view down to their mobile database, that mobile database pointing back to the correct table.
Right, but the problem now with ParallelFox, instead of multiple users trying to use the DBC at the same time, you now have multiple workers trying to use the DBC at the same time. So the same problem comes back. The solution I had to that was you can compile your DBC inside an app or EXE rather than distributing it as a separate file. That effectively gives each worker its own copy of the DBC. A potential problem with that is if you use the connection within for remote views within the DBC. If that's a problem, consider using the constraint clause for views rather than doing that.
I assume that would also break if you're running your application on a remote desktop server, since everybody's running the same executable.
Yes. Yes.
All you're using code, it doesn't look at a DBC anymore. And of course, if your DBC changes, then you have to take this.
Yes, right. Okay. You know what? I'm going to skip this last little bit. Okay, so to wrap up, what we talked about today, we answered the question, what is ParallelFox? We went over the basics of how to use ParallelFox, talked about some tips, tricks, and traps. Added several new features in version 2.0, and I won't go through every one of these. A quick word about VFP Advanced. I did do some work on that, but it's a work in progress. If you want to use VFP Advanced with ParallelFox, check the white paper. There is partial support. As far as the release, on GitHub coming soon. I've got the code done, but I need to do some packaging work to get that ready for full release. I'm also hoping to bring that to Thor Check for updates, which will end up being the easiest way to install it. But for everybody here and online, the release is right now. It's included with the examples download is just a full copy of the ParallelFox folder.
You're supposed to tell us to look under our chairs. Under the chairs.
Under the chairs. No, it's not under the chairs. It's in the laptop. Okay, that's it. I'll hang around for the Q&A session. Please fill out your evaluation, and thank you very much.